Hello, everyone. As we all know, this March, the world and the cinemas will see a long-awaited second part of the Dune movie. I need to say, I really like the first part, which was filmed and released in 2021. Many people around the world are waiting for this movie, or this Dune universe has quite a lot of fans, and it's not just a movie, right? It's been based on a book, on a novel created by Frank Herbert in 1965. It has a really well thought through plot, really interesting characters, really diverse, interesting, and multispectral range of topics about architecture, about politics, about economics, about society, about design as well. And what me and like a lot of people really like about this universe is that everything is very based. Everything has really good, really logical reason to exist. Even like their shields, their architecture, their design of their planes and planetary gates, everything has really solid background behind it. That makes this adds extra dimension to this universe, and that's what makes it really appealing to so many people. More than that, some people even think that if for the first movie, the one from 20th century, if it was better, it could have changed our perception of sci-fi completely. So right now, we would not be thinking of sci-fi looking at Star Wars or Avatar. We would instead be judging sci-fi by Dune, because his universe also has quite a big aesthetical component in it. It's quite interesting to actually see how this movie was inspired by some of the real world architecture, some of the political and historical, right? Interprets it quite nicely and quite interestingly in this future. Also, not only on our planet, but on many different planets. As an architect, as a computational designer, I thought that it would be nice to try to model it, try to give my interpretation to this universe, because I need to say that CGI artists who were working on the production of the first part and on the second part, as far as I can tell by watching the trailers, they did a great job. They did amazing scenery, amazing locations, amazing architecture. So I thought that it may be really nice to actually to try to represent his architecture, to model it myself. And after discussing it with my colleagues, we thought that, well, maybe we can make an entire series of videos on model things from Dune. By the way, let us know in comments what you like to see, because we'll start with architecture, but maybe we'll also show design, some technologies and so on, because for us it's quite interesting. So I picked the planet Arrakis, which is the one where the first part of the movie takes place, and I think the second part will be taking place on that world as well. This is a planet which was quite strongly inspired by the Middle Eastern architecture and Middle Eastern history as well. And I thought that it might be really interesting to model a few of the key elements of the architectural world. And I decided to start with the Arrakis, which is the capital city of that planet. And I thought it might be really nice to model the urban fabric of that world. And yeah, I will be using the Grasshopper to make a definition which enables us to create this fabric and these buildings. So before we actually start making it, I thought that it can be quite nice to decode it, to analyze and to try to understand how it works. I created a list of the most, let's say, representative images that I also personally find the most appealing and most spectacular. And I think it would be nice to decode the logics of these images and this architecture and trying to recreate it ourselves. Let's go. I picked a few images which, in my opinion, are quite representative and allow us to see some more details and some more parts of this universe and this world. And I think that for the first part of our Dune related tutorials, I would like to model this space, which is the urban fabric of our key. I'm going to keep this image just as a reference, and maybe we can dedicate a couple of minutes just to look at this space and outline the key parameters of this location, because in order to model something, in order to script something, we actually need to first decode the logics of this fabric. Basically, any city has its own logics, and as follows, its own fabric can be decoded and then recreated using some parametric or procedural algorithms. What can I tell looking at this mass? Because you can barely see some gaps between the buildings. It's mostly like a solid texture, I would say. Well, three-dimensional, but very solid as well. Of course, I can see the palace, which is like the main building, the dominant of this environment. I can see the mountains, and I can see the larger buildings, or I can see the massive smaller ones. It looks like this thing is based on a very orthogonal grid, which, however, sometimes it gets some inclined streets. Of course, they are horizontal in 3D space, but in plan view, they are not going at 90 degrees. We also can see that a lot of these buildings actually have more or less the same height, but they're still a bit different. But this gives us another parameter, which is quite important, which is the height of these buildings. And then we also see that almost every single roof of these buildings is actually tapered. And then it also gets divided into small fractions. In the end, we get this really dense three-dimensional city with really active and dense and very sharp texture, like also three-dimensional texture. You need to zoom in to really look at it. It's quite hard to tell where one building finishes and the other building starts, but I think this is the fun of analyzing it. And I think the 3D modelers and the CGI artists who are working on this design, they probably invested quite a lot of time and effort and thought into actually modeling this. I'm not sure if they used any procedural algorithms or softwares. I'm pretty sure they did. I don't know which one exactly, but it will be interesting, by the way, if you have some insights on that, you can leave it in comments, or you can also share your thoughts. What would be the most appropriate software in your opinion? I'm always interested to see the other perspective as well. Basically, I think I already kind of have an idea how we should proceed, and as follows, let's just start. I'm going to move these images a bit to the front, so we have enough space in front of us to actually model things. Maybe I want to move on a bit more once I start in the city. And I'm going to open Grasshopper and we can start. For this exercise, we will need some plugins in order to make it work easier and better. I would say the plugins that we need are going to include the following. It's going to be the Tree Sloth plugin. It's going to be the Buffelfish, the Lunchbox, the Human. The Human is a plugin which we'll be using for texturing and applying materials, which is quite interesting as well. And I think it's going to be, we might use some tools from Terra, but it's not compulsory, let's say. I would say that's it. If you don't have these plugins, you can always download them from Food for Rhino. I hope you do have them, but if not, you can just download them, pause the video, and then you can restart once you have them. Let's move on. Let's start from creating the base grid. I'm going to start with making a rectangle. I'm going to set my file up in meters. I'm going to make it something like 500 by, that's quite a lot, by 300 meters. Of course, this is not the entire city of Arrakis, but it's a portion of it. I'm going to scale these things up. We can have it as a reference and also don't have to zoom in too much to actually be able to see it. Something like this. And from here, I'm going to get it. So, okay, first of all, let's start with defining the base city grid. I would argue that it's the best tool to achieve it will actually be to use the algorithm called Substrate, which is this one. Right? By default, it already gives us quite a similar aesthetics, but I would still want to set up the angles myself. I would go for merge, I'm gonna go for degrees, because for us as for architects and not mathematicians, it's easier to work with degrees if you work with gradients as well. I would set something like, and I will also start from making not too many of these lines. First, I want to get the larger fractions, districts, if you want. And let's say we start from something like 0, 30, 90, and maybe 30 again. Something additional else. I mean, we can also experiment with these tools. We can always get more or less of these divisions. And of course, the seed, we can also control the seed and then make a slider from 0 to 100 and then control, I would say, I actually kind of like the first iteration. It was quite nicely. This one was also not bad. I was continuous style on picking the best option, but I think something like that should also go. Let's say 57. Now it's 100 and the original one was splits. Wow. I think that was not bad. Okay, so let's say this is our base and we're gonna start actually maybe we're gonna drop it a bit more. Yes. 6 should be fine. Yep, okay. These are our districts. They are a bit different in size, but for now it's fine. Then I would like to divide this shape into some of the panels. I'm gonna take the random quad panels because I want to add a bit more randomness to this grid. And before we actually divide it, we need to start from splitting our surface using these lines. We take our original our rectangle, we turn it into a boundary surfaces, which is this component. And we have to split it. We'll do it like that. Once we have it done, we need to take each of these surfaces, we need to draft it, we need to shrink it, shrink the surface, out. And after that, we need to apply this trace. I would say this is fine, but I really want to take the dimensions of the surfaces and actually use them as a base. So say division. And let's say 20 meters maybe. Well, we'll create 2 sliders just in case. Okay, so second. What do we do? Also, the seed can be also different for different parts, but for now it's fine. Maximize it a bit. And the seed, I'm gonna create a new one from 0 to 100. We'll see. Yeah, I mean, it's all about finding boundaries that you like. Well, we'll take the B-rep edges again, and we use these edges to actually split those surfaces for each of these. Of course, when we say shift paths, we basically get more of these lines in one step. We also say remove duplicate lines. I want to say split surface. So this. And as you can see, we're getting something like this. I mean, already quite happy with where it's going. Just the file post. Let's see if we can get something different here. I think the original one was fine. Actually, this one was also quite nice. Actually, kind of like this one. Yeah, let's go forward with something like this. All right, this is fine. By the way, what we can also do here, if we feel like it, we can also take the B-rep edges. We can join them. And we can turn them into boundary surfaces. You see this affects the orientation of the panelization quite a bit. Just let me keep this option for you here, so we can always have this option. Okay, let's do the final step before we start turning it into 3D mossing. I want to really add more division to this. I would like to take the substrate once again. And you might ask, why don't I just increase this number here? Well, it's because if we increase the number here, every following subdivision gets smaller and smaller. So it doesn't create more large subdivisions. Instead, it keeps subdividing those large parts into smaller ones. If we really want to have the big chunks and then divide them into more uniform fragments, it's better to do it like this. Next thing I want to do, I want to say remap, and I want to make sure that this number of lines is defined by the area of those surfaces. Let's say here we take these areas, we take the remap numbers, we take the bounds. I'm going to flatten the bounds. I'm not doing the division because in this case, the largest panels will be divided like that, which I don't want to. All the construct a domain for one, domain for two. So the smallest panels will divide just into two by only 2 lines. And the largest one can be, let's say, 9 lines. Let's craft it's fine. And then the angle, I want to keep it orthogonal. Now, once we have these larger districts, I want to keep this as orthogonal as possible. As you can see, this is what we're getting. All right. You know what can be smart? Actually, maybe you can say found rectangle. And of course, we need to say cloud. So each of these boundaries will be independent. We can say this. No. Anyway, it's fine like that. I think I'm going to keep it like this. Then we'll say split surface. Or actually surface split. We use these lines, or use those surfaces. So we basically get it more divided into more halves. Just one more thing for chain forward. Wondering why is this part and well, let's see. We'll take the gear edges, let's say chain curves. Hold on, not such a big deal, but well, is it? Let's go for something like this. Actually, prefer this station. All right, maybe actually we can increase this number to something like 10. This one maybe. This is fine. 12. That's all good, I think. All right, now we have these parts kind of ready. And now it's actually time to start building these three-dimensionals. Let's take these surfaces. Again, we have to craft them. Well, I'm going to get rid of all the extra zeros. Although I normally say that it's not always a good idea to simplify the tree, but right now we don't really care about it. So we can just do it. And let's start with creating this build. I'm going to take the view up edges component. I'm going to join it into curves. This. And now I'm going to randomly extrude it. I'm going to say extrude, and I'm going to use this curves as a base. And then we just need to say random. After that, we'll basically take the tree statistics to actually find out how many values do we need. And then we control the height of these builds. Let's say I want to start from 4.5 meters for the smallest ones. Then we need to go as high as 18 meters in the tallest ones. Now this is just the straight part. The tapered part will be going on top. It's going to be more like the roof. Yes, it lofts. You see, this is our urban trick. This looks quite similar to a standard city, I'd say. We just increase the number of halls here, just to increase the density of the. Oh yeah, actually, it's not really liking this part. This can be pretty cool. She's not very there. Anyway, let's just move on. I can stay for design changes for hours. I hate to stop sometimes. Let's take these curves and let's also not only extrude it, but let's also move it. Why the way to move it? Well, it will so understand. These parts are actually just the vertical walls. This is probably the least interesting part of the script, which we still need, but the fun begins here. We'll play down a bit and hold stuff on this part. First of all, what we need to do, another plugin that we need to use is called People. It's an add-on to Rhino, while also Rhino and Grasshopper. We need to use one particular component, which is called offset polyline or polyline offset. Now, what we need to do, we need to offset those lines by a certain distance. Again, going to use random. Probably not such a big surprise for you guys because it's quite simple and straightforward, this login. But this time I really want to use of course, I'm not going to use such high values. I'm going to take it from 1.5 to something like 6, maybe. I'm going to connect it here, probably distance. And if we connect a curve container to H, which goes for whole, we can take the inner curves. You can see that some of them even don't exist anymore. Here, for example. It's important to say field 3, basically to remove the empty branches, and then we need to say field all unmatched. We take this path and we take those curves. We also need to say shift paths. Yeah, we'll get the same length of the paths, but then we filter the long matching ones. We'll get how many ones? 8 here, 6. I would say let's call the default or style changes this principle. And this one like principle as well, basically, and getting. You see, before we had we had many more branches than, but we had 207 branches and now we're only 103. Also made need paths. And why do we need to need? Because some of the buildings, the smallest ones, they won't have the table roof, they will have a flat roof. We need to take not the curves, but we need to take the extrusions. Right? Also, the same paths. You see, we're getting those extrusions, right? We can just cap them and forget about them to walls before, I mean, not forever, but before the end of this script. Of course, we can also take these curves, right? So you take these curves, well, because we might need the roofs separate. Also, we need to have these two separate key. You're going to highlight it in something like ink, maybe, or black ink. Yeah. Something like this. So if we want to use it, we can basically just always know where it is located. And then the next part is actually quite fun because now we're going to be making the tapered roofs. Here I need to say a couple of words about tapering geometry in Grasshopper. I think Grasshopper is quite a cute tool, but tapering it, what should I say to not offend anyone? I mean, I think it's pretty bad. I'm sorry to say that, but in some other 3D softwares, this thing is resolved a lot better. But as usual, I'm not here to point fingers, I'm to make things work. What I did, not myself, but together with my colleagues, we actually developed a workflow which allows us to make quite a decent taper in Grasshopper. And of course, we use meshes, but then you turn it into a VREP, so it can be a fully functional VREP, which will work as a very clean geometry. Enough. So okay about it, I'm going to show you how to make it. Let's say we take these curves and we turn them into boundary surfaces. We take the outer curve and we take the inner curve. These are the inner curves, and in one we have outer curve. So merge them together like this. It's also very important to have the correct data structure here, because in this case we can get these boundary surfaces quite clean and nice with this. And then I will have to turn these curves into a VREP mesh or mesh VREP. The resolution doesn't really matter. What matters, actually, the lower the better. I think by default, it's already pretty good. But what comes next is actually extruding it and turning it into a slopey roof. I need to say deconstruct mesh. Yeah. And also, by the way, guys, I mean, if you know any really good ways of turning it into Dune paper, I encourage you to write it down in comments. I've read most of the ways to make it, and I think this one I'm going to show you is probably the most efficient. Also in terms of time, it's quite fast. Let's take those curves from the inner side. We pick the curve which points the closest to the inner side of this surface. We say call path on, and we keep only those vertices which are closer than 0.1 meters, like this, which is basically 10 centimeters, which is nothing. And then we keep only those vertices. After that, we'll move them. And of course, we can also move them at a random height. I'm going to copy this bit again. Well, for I need to drag this group a bit higher, so we don't all collide. And we need to take these meshes as a base for the tree statistics. And here, this is going to be the height difference. After that, we just connect it to Z. And you see we're getting 143 branches. And here we also have 143 branches. We'll move it. And then, you see, what we need to do next, we need to say replace items. And we replace the old vertices with the new vertices. How do we get the indices of the old vertices? We take these old vertices, we say item index. We use them as an item and those vertices as a list. And then we use it as an index. And the original vertices from this mesh, we use them as a list here, right? Then we say construct mesh. We take these vertices, we get those faces. By the way, this is coming not from faces, it's coming from the other ones. I'm probably gonna move it a bit, so there's no confusion over there. And we take those faces, so we can even here. This is what we're getting. You see, basically, it's a really clean. I mean, as much as possible. Mesh, it has some unnecessary extra faces, but we're going to get rid of them in a second. Once this is done, we just need to say weld mesh vertices, this component. Well, like this one, but actually, I think we don't need to weld because it's each of these meshes is a separate joint mesh. It's actually should be fine. We just need to say mesh to poly surface. Oh, that's all. And after that, we need to say merge faces so that all the co-planar faces are going to be merged. And you see, we're getting a really clean, really nice and smooth, well, actually sharp, but clean geometry. This is it. Done, basically. And this is not a lot of a script. Once this is done, we just need to take those curves. Again, we take them as a separate container. And we create boundary surfaces from them. I need to say, guys, that even though I think this script is quite clean, but substrate, normally, not always it produces a really clean result, especially if you get some really small parts like this one, for example. Sometimes it can be as small as the tolerance. We all need to be careful with using this tool. I forgot to move those curves. Here now. It's important to move it by the same height as we did for the vertices. So there is actually no gap between them. Again, we're making a conceptual texture. So we don't really need to make sure it's completely fabricatable. Of course, we can achieve it. Maybe it can take a bit more steps, but as is, I think it should be quite fabricatable, so to speak. Then let's take this CMP and let's just merge all these things together. These surfaces, these taper grooves, these and these bits, these actually need to be together as well. But also what is really important is that we should not forget the walls, which are here, right here. We take those walls and we also bring them together with the rest of the job. Like this. You see, basically we are getting our city almost there, but not yet, not so fast. We can also merge all those bits together. It's very important to be attentive and not to confuse everything. Actually, this is not the final, it's not the final design. Actually, we have a completely messed up tree. I would like to actually clean it up a bit. Here, for example, we're getting this tree as a principal, and this one should also be principal. It's really important that we are getting these data branches in order. For example, this one is really messed up. It has a lot of extra unnecessary zeros. I can simplify them all. If we don't want to simplify, what we can also do, we can also say match tree. Simplifying is not always the best idea. And if we have identical lengths of data trees, we can pick the one with the right data structure. We can make it RC, for example, this one does have the same number of elements. So we need to take this one and you just say filter unmatched. And you take this as 1, and we take this one as 0. We'll get those ones here. See now, so much. We connect all of these 3 match trees here. This one, this board. All right, seems like we're getting close in order. And you see here we have our trees matching, which is good. But this is fine. This we can take the custom preview just to see how it looks. And I would use random mode for that. And I will also say I'll preview to all rest. What about the color? Probably. Well, it's actually quite a good color for understanding the shades and the lights and so on. I think it's made for a reason. But I'll rather do something more like Dune. And actually, we're going to talk about texturing it in the later phases of this tutorial. This already looks quite fine to me, but I want to add a little bit more resolution to it. Let's get those flat surfaces and those inclined surfaces. And these ones they don't have any inclined surfaces, so we have it flat. But these ones, I actually want to make a bit more fun with them. I want to say deconstruct B-wrap. I'll say shift bots. Let all the faces that belong to one B-wrap are gonna be in one tree, in one branch, sorry. And then I want to say substrate again. And basically I want, because substrate is actually plane sensitive, it applies to the plane where your surface is located, or to your surface where it is located. You don't need to worry about the inclination. Let's take the area, right? And let's actually divide it into possible way. I don't want us to use each and every of these surfaces. I'll actually go look at the later stages, so it's fine. Yeah, let's take those areas. Again, we're going to use remove. We'll use bounds. Again, we flatten it so it applies to the entire tree and not just to every separate branch. And the construct domain, I want to make it from 1 to something like, let's say, null, maybe. Yeah. And we apply it here. We're getting something like this. Also, the angle should be 0 and maybe 0 should form. Maybe we can make it, we can merge it. Let's check if it works better if you apply 2 angles, something like 60. And we need to turn it into radians. Well, it's not so sure. I'll go for 0. I mean, your full guess, guys, but I think 0 is the best result so far. Right, and then basically what we need to do, we just need to say surface split. This and here. Yes, well. You need to actually plot it. There. You see some of these surfaces that got split, and now we can also extend those curves just a bit, just to ensure that the intersection is actually happening. I would say 1.5 meters should be fine in both directions, of course. Here we're getting those surfaces split. Let's take the B-wrap edges and let's make the offset using the CJ curves. I also want to increase this number to 12, maybe 15. I think this looks a bit more lively. And now let's say offset 1 So we say offset 1 we need to take just the planarity of those curves, and then for the offset I'm going to use something else 5 meters. And of course we take the holes, which are the internal holes, right? Yes. And now I want to add some three-dimensionality to it. I want to extrude them, also using some variable heights. But what is really important is that we need to extrude them always upwards, not downwards. I would say let's test if it's oriented, if it's pointing down or up. Well, to achieve it, I'm going to test each of these curves for polarity. I'm going to deconstruct planes. I'm going to take the z vector of those planes and I'm going to calculate the angle between the z vector and the world z vector like this. And then if this vector, this angle is smaller than, let's say, 20 degrees, if it's smaller than, let's say, 60 degrees, then the curve should be flipped. Because in this case, it's basically pointing downward. Take those curves, right, like this, and we say flip curve front. Yes. And then we basically just need to turn it into boundary surfaces. Yes. Okay, some of these curves are not existing. We need to clean tree out after the offsetting polyline. There we go. All right. And then we need to say extrude. I want to extrude them randomly by, again, we use the random, we'll construct the main. The thing is, if we're doing things procedurally, we need to always use quite a lot of pseudo randomness. That's why we're using this component so much. But of course, it's not compulsory if we have some attractors or want to make this thing work with attractors or something else. Yeah, well, in feature it. It's just we need to know what are the attractors based on parameters. And then we say we need to take the vector. The vector is going to be defined by the orientation of the surface. We say view of closest point. We take the normal amplitude, normal number. It's important to draft it. We can have it here, and then we can paste it here. It takes a bit of time, but then we're getting something nice. Let's merge it with the rest of the geometry. This is very complex thing that we want to make it principle. And let's see. I would say we need to say shift paths first. So we can actually bring those groups into the corresponding branches, and then we also need to say match 3. So 40, and getting the same number of branches here. See? No? Seems like it should be minus 2. Oh? Okay, we don't really care about this data structure right now, but I can just say, let's see what is a single branch. Let's still test it. True statistics, although we don't really care about it for the rendering or visualization purposes, it's still supposed to understand what is going on with the scripts or whatnot. Let's see. Let's see. Okay, all these parts are actually belonging to only one. This is actually fine. It seems to be alright. What is the issue? Let's try to take this one. And let's try to match to here. Yes. Oh, okay, got it. Because we didn't have this. Okay, fine. We can actually merge it after this phase, after this stage, we just merge it. And this is it. You see, we're basically let's okay. Wait, connect it here. Ooh, wow, this is already a real lot of clips. You just go in here. But I think the 6 or 4.5 is probably a bit too much. And I'll drop this number a bit. And the last but not least, I would like to get rid of some of those things here. right? I want to get rid of some of those parts. What I want to say random edges, and I want to remove, let's say, 36% more or less from each of those branches. So we take the length of each of these branches, we remove 36% of the elements. This is the reduction. We're getting rid of many of these panels. Some point we're not getting this readability. I actually personally rule out how it looks overall. And I mean, it's quite simple, quite straightforward. We spend around maybe 30, 40 minutes on doing this. Of course, I'm sure these guys have spent a lot more time on designing all these things and doing them carefully. Second, it's much easier to repeat than do it from scratch. But, I mean, of course, it's always it is here, but I think it's quite close to being good, let's say. Last but not least, I want us to apply the texture to this thing, because here what also makes it look pretty cool is the texture, which somehow it blends with the environment. Well, those all the same materials as rocks, but as well, it's also standing out a bit. You can also tell what is the shape and what is the law. The last phase of our tutorial is texturing with Grasshopper, and not just texturing with some material and some transparency, but actually using some Rhino materials. Before we actually do this, we need to use a human plugin. But before we do this, we need to create our materials. Let's make our material. Let's assign the texture from already prepared a special folder for that. I want to get 2 custom materials, and I want to assign different textures to them. Well, one of them is going to be white, the other one is going to be more yellowish. And this one, I want to this. But I want to make this texture a bit more orange. It should be something like this. I'm going to change this percentage to 60. This texture gets a lot more orangey, and this one gets more whitish, let's see. And let's add another layer, which is going to be called the materials. I'm going to make 2 cubes in this layer. One of them is going to have this color of this material, and the other one is going to have this material. And something like this. And then we need to bring these 2 B-ups into Grasshopper. We'll set multiple B-ups. And then we basically can take the, we need to go to human plugin. We take the waffles, we take the object attributes, and we're getting these 2 materials. You see there are 2 of them. I'm going to graft the output of these 2 materials, and then I need to divide all my blocks into 2 specific materials. I think actually this bit is, I think we have to say here. Okay, getting the goods tree. And I want to assign it branch specifically. Let's say we need to say we have just 2 materials. I'm going to say split 3. Yes. True statistics. We're getting all the bots with a random made list. It's a component from our Launchbox plugin, which it hello soon. And I'm going to control the ratio of those colors. I'll take list item. Instead of crafting it, actually, you can just separate 2 materials. And then what is important is to actually map this material on, because basically it's going to look, if we do it very, very like abstractly, it's going to be something like this. What I want to do, I also want to change the seed a little bit. It's a bit different box. This is called font here. And to use mapping. In human, you have the texture mapping, and let's take the box mapping here. I'm going to take a bounding box. For each of these things, I'm going to use this as a box, and this branch I'm going to use it as a mesh. Or we take the UL box. Basically, it turns our object into a mesh with the texture, with the UV coordinates. I'm going to take this custom preview and apply this texture. And you see, basically, we're already getting this material here. And basically, the same way I'm going to copy it, I'm going to connect it to negative. I'm going to do it with the other material. Now I can already tell that the difference in colors and shades is probably quite high. So I'm going to change this color sample of this as well. And it's quite an annoying part, but we need to recollect this view up here. This one I'm going to make it less orangey, and the other one I'm going to make it a bit more orangey. But you see, now it's a lot more balanced, probably. This one I'm going to make a lot more orangey, so I'm going to blend them a bit more, because you see now I think it's getting a bit closer to what we need. Maybe I'm even going to make it a bit more red, and this one as well. And again, I'm connecting it, and then we connect the sun. Oh, this is quite a lot. Fall. And then you want to make it a bit more. There we go. I need to say I'm quite happy with the result actually, because I think it's not bad. And you can appreciate, hope you can appreciate how simple it is to do using a human plugin. And this entire thing is, I mean, it looks quite long, but it's a really simple script. Very straightforward. And of course, we can save some views if we want to. But also fine. But this is the beginning of our Dune's tutorials. This is the Arrakis, the main city on Arrakis, the main planet of Dune universe. And the next time, hopefully, he work on the palace and some other designs. But if you have any other suggestions about Dune universe, or if you would like us to model sci-fi architecture from any other universes, please let us know. And we will be more than happy to help you with that, and to make a tutorial about it or to make a video about it. Also, I would like to let you know that myself and my colleagues, we provide online classes about Grasshopper, about browsers, about other softwares related to 3D modeling. And if you'd like to arrange an individual session or group session, please let us know. We're always open for collaboration. Also, if you'd like to support us, check out the parametric design market, which is going to be added to the description of this video. We are posting ready-made scripts and 3D models there, which you can use in your projects. You can keep in them. And if you buy them, you support us and help us do more videos, better videos. Thanks everyone for the attention, and bye.